start with, I just started a brand new third person template. So go ahead and open one of those up if you're following along. In here, we're going to create a few things. We're going to start with a Niagara emitter. So go to FX, Niagara emitter, do a new emitter. And for this, we want to do an omnidirectional burst. Select that, say finish. Now let's just name this NE Flamethrower for now. Go ahead and open that up. For these, we're going to kind of go through each one of these to make this look like we want. If we see right now, it's just a burst, which is not what we want for a flamethrower. So let's go to the emitter state, change lifecycle mode to system. Let's get rid of spawn burst instantaneous. We can uncheck that for now. And let's add an emitter update. And let's say spawn rate. For spawn rate, let's set this to something like 500. Now we're getting a lot more action over here. Let's go to initialize particle. We want to do, you can play around these numbers, make it look like you want. I'm going to do 0.5 to 1.5, so it'll be a random in between those. Let's go set the uniform sprite. Let's go 0.5 to 25. So now we have anywhere from little particles up to big particles. The rest of that looks good for now. Go over to your shape location. We want a sphere for this, and let's give this a radius of 5. So a little smaller initialize location. And then do, that should be it for this one. Let's go to add velocity next. And this should be good as well. Do a particle state's good. For gravity, you can play around with this, but we're going to leave it at Earth gravity right now. Drag, I have it set to 0.5 for now, but there's not a big difference between that. 7.5. For scale sprite size, let's set, we want this to start at 0. It's going to at half a second be at half of its size. And then for the last one, let's do 1 and 1. Set the scale curve to 5, which will multiply it by 0.5. You start getting a little smokier look to your particles. Go to scale color next. RGB and alpha separately. These are going to be 1. And that looks good for that curve. This will have them start at full alpha, which is fully visible, and over time they'll slowly disappear. Here we need to add a linear force. For this linear force, we want to give it a fairly high number here, so do something like 50,000. And now you have more of a shooting effect here. Let's add a curl noise force. just to give a little variation in our animation. I want to do 1500. It's a slight little kind of wavy, curvy effect that it's adding to it. Solve forces and velocity. Go ahead and check the speed limit. So this is starting to limit how fast it can go as it goes out. If we raise this, it goes far out. If we bring it down, it limits it, makes it even shorter. So kind of wherever you want it. For now, I'm going to leave mine at 1000. And then for color, let's go ahead and add a color. For now, we're going to set this to a custom color, but we will end up allowing the user to change this in the scene. So for now, just do something orange, kind of looks like fire, maybe a little darker. For a sprite renderer, you shouldn't need to change anything here. Then if we go to, let's check the rest of these real quick. Okay, so that should be good. And now we have kind of a cool little flame. You can add other emitters once we get to that point to have variations in colors, and you can use different color curves to affect this. This is just what we're going to use for this for now. So now, next, let's save this. And now let's start a Niagara system. Do new system from selected emitters, and next. Then go to parent emitters, and here select your flamethrower that we just created. Go ahead and add that, say finish. We'll call this NS Flamethrower. Don't need to do much here. One thing we will do, if you go to color, click the little drop down, and we're going to say user. Let's see. Yeah, select the read from new user parameter. This will expose it so that we can change the color in our blueprint once we set this up. So it'll default to our orange that we have set. And we'll be able to change that in our blueprint. So that's all we're going to do in here. Compile and save that. Next, let's go ahead and create a blueprint. Make this an actor, and we'll just call this Flamethrower BP. Let's open that up. In here, you can add any kind of mesh or item that you want to actually house your flamethrower. It can just be the flame or whatever you want to do. For this tutorial, we'll just add a sphere, just so we don't have to use any paid assets for now. And then the sphere, see what kind of colors we have. Kind of do something funky. That's just a mannequin material, but kind of looks unique. So we'll do that for now. And then on this sphere, we want to add a Niagara system, and we'll call this our flamethrower NS. Let's start in our jump over to our event graph. And in here, really the only thing we're going to use right away is this event tick. So out of this, we want to grab our sphere, pull that out. Now we're going to set up to allow our sphere to rotate. Let's actually pull this into the world and see where we're at for now. So we're not getting any flame. We need to go to our flamethrower and set auto activate is on, and we need to set this to our flamethrower. That would help. So now we see our flamethrower. Pretty cool little flame. May look better if it was a little shorter, but we'll leave it like that for now. You can always go play with the settings, add other emitters to it, add some a similar emitter but maybe smaller, and make it gray or black. Would add a little smoke to it as well. For now, let's work on making this rotate towards our player. So back into our flamethrower blueprint. Come off of your sphere, say get world transform. Oh, sorry, get world location. We want to see where our player is at with respect to our players. So say get player pawn. Off of here, say get actor location. And then we're going to use a find look at rotation. We can set this to where it will rotate in all directions at our player, but for now, let's split this. I just want to rotate around the z-axis so it'll stay on the same plane. So from here, let's say make rotator and just connect the z for now. And then from here, we want to say combine rotators. This will allow us to offset the rotation if we need. So we'll test this once we get it set up and see if that's necessary. If not, it will stay on its same rotation. Then we'll do an R-interp2. We actually want this to be connected to the target. Pull your sphere back out and then say get world rotation. This is what it's going to try to look at. For the interp speed, this is going to be how fast it attempts to turn towards the target. So we actually want to create a variable for this so that we can expose it and kind of change it depending on the actor that you want to set up. Let's set a default value here to maybe start with 1. We might want it to be faster, we might want it to be slower, so we'll work with that as we go. For the delta time, we actually want to pull our event tick over here and use this delta seconds. And then for off of our return value for our interp2, we're going to say set world rotation, and this is going to be for the sphere. Leave all that for now. The next thing that we want to set up is we want to be able to change the color as we see fit. So let's do a make color here. Let's promote each of these to a variable, and we'll just leave them at named what they are. We can leave the alpha for now, or we can promote this to a variable, but we'll default this to 1. For now, we can do a default red and leave the other two at 0, so it'll just be a red flame, and then we can play with those. We want to expose all of these variables so that we can use them in the editor. And then from here, we're going to set this color. So pull your Niagara System out and say set color parameter. Connect that up. And then this parameter is going to be this color. We need to give this parameter the name of that variable that we set, which we called color. Let's see if we can should just be color. And then let's go test it. Once we start it, now we have a red flame. We see that this is actually, it's moving, but we need to adjust it a little bit. So we'll go back in here to our Z, and we'll try a -90 to start with, see if that's a little better. Yep, and now it'll turn and try to use flames on the player. So the color doesn't take effect until you're actually playing, so we can set that the color that we want here, but we'll have to play it to see what it looks like. Let's just mess around with some of these colors. See what that looks like. Kind of a greenish white. Kind of change it however you want, depending on what it is. So the other thing that you can do on this is we set the interp speed to be a variable. So if we do 0.5 and see what that does, it'll turn quite a bit slower. Or you can make it more difficult by turning it up a lot, and we'll see now that turns a lot faster. Set it at a really high number, and this pretty much keeps up with the player. So we can adjust that, and then we also have this to where we can adjust the alpha, making it a little less visible. So you can play around with those and make it look how you want. So I moved a few more of these out into the world so that we can see some of the variations and colors that we can get. And all these are trying to spray me. Again, you can adjust these, make them shorter flames. You can make them get bigger at the end and smaller at the beginning. Just feel free to play with it, add some more emitters to it to get the effect that you want for your game. So that's going to do it for this episode on creating a custom flamethrower effect using the Niagara System and Unreal Engine. We covered setting up the particle system, building a custom actor, and then we combined the two and created a dynamic and interactive in-game experience. If you enjoyed this content and found it helpful, please don't forget to hit the like button and subscribe to our channel so you don't miss future episodes. We'll be working to set up various Niagara effects that can be used in your game, as well as setting up collision detection events so you have these effects interact with your character. Thanks for watching. As always, happy developing, and I'll see you in the next one.